Okay, latitudes are imaginary lines on the Earth's surface. It varies from 0 to 90. So as you can see, if you see the globe, these are the pole, north, south, east, and west. So the line that runs from 0 to 90 up and down are called the latitudes. So, and it varies from 0 to 90. Okay, the one in red is called the equator. That's latitude 0. So why others, they are not 0, so they could be 10, 20, 40. So as you increase towards the north or south, it increases to 90. So the maximum is 90. So from 0 to 90. So this could be maybe 30. Maybe this is 60. So that's it. Why again this could be 30, maybe 60. So it increases from the equator to north or south from 0 degrees. So this latitude is called, latitude 0 is called the equator. Okay, let me write. So latitude 0 degrees is called the equator. So that's very important. So let's look at longitude. Longitude are imaginary vertical lines on the Earth's surface. It varies from 0 to 180. So as you can see, we have, as you can see, they are running from, like the former one, the latitude runs from equator to north or south, but this runs from the, we call it prime meridian, that's longitude 0. So let's use this red one. This is called the prime meridian. If you don't call it, you call it Greenwich meridian. Greenwich meridian. So that's longitude 0 degrees. So it's so increase. Maybe if this is 0, this could be maybe 70. This maybe 120 to what? Maybe 18. So this something. This maybe, if you take this as 0, so depending, 70, and this is maybe 150 to 180. So it runs from 0 to 180, west or east. Okay, let's move to location of points. So for us to locate any point on the Earth's surface, we need to know the latitude and the longitude. So the point of intersection of the latitude and longitude is the place we are looking for. So know that the intersection, to locate a point, we need the intersection of the latitude and the longitude of that place. So example, now if we are to locate, and mind you, we always locate a point, is always written latitude followed by longitude. So the easiest way to know is by so to locate a point, the first one is always the latitude, while the second coordinate, the first coordinate is the latitude, while the second one is the longitude. So as you can see, north, south, south. So whatever that you see here must be either north or south, while whatever you see here is either east or west. So let's now locate these points. So the first one, let me change color. Okay, let's use the first point, they said 60 north, 60 west. So the latitude, remember, starts from 0 towards north, so 60. So if I can, let me take this as 60. So we've located 60 knots because it's either north or south. Down here is south. So why 60 west? So look at west. So let me take this as 60 west. So that's it. So this point, the point of intersection, this is our latitude 60. So this is my point. This is my point. So this is point A. The point of intersection of 60 north and 60 west. So that's it. So coming to B, 60 south. Okay. Let me take this as 30. And let me take this as 60. So it must increase tonight. So I've located my 60 south. So remember, this is always up is north, down is south. Why 30 east? As okay, this is east. This is so let me see. Let me locate this. Let me call this as. Let me call this 30 east. So what was the point of intersection of 60 south and 30 east? That's it. Do you see it? This is the longitude 30 east. Why this is the latitude 60? So this is point B. So as you can see, it's very simple to locate point. YC is 30 south and 30 east. So as you can see my 30 east, why this is my 30 south. So this is point C. So it's very easy for us to locate points. Once you know the longitude and latitude, the point of intersection becomes the place we are looking for. So let's now move to distance, calculating distance between 2 points along the longitude. So this is very, very important. For us to calculate the distance between 2 points, we need to know this, that the 2 points must have a common latitude or a common longitude. Yes. So for us to calculate the distance between 2 points, the 2 points must have either common latitude, if it's the distance along the latitude, or common longitude. So that's the first thing. So since we're on longitude, so they must have common longitude and different latitudes. So that's it. So we're on longitude. So assuming I want to calculate like this point, so assuming this is a longitude, I want to calculate distance along this longitude. So maybe if I call here A and call here B, so what do you notice? They must have common longitude and different latitudes. So if I call here maybe theta 1 of north, why here could be theta 2 of south. So that's it. And again, remember, this is a sphere, like a circle. So and as you can see, the distance between A and B is the arc of a circle. So we can get the radius, the circle, because this is like the center. So we need the radius. So if we join O to A and O to B, we have the radius of the circle. So the radius of the circle is r, big R, which is, remember, if you notice, they are all big circles, so they are all the same. But for latitude, I forgot to say that, you notice that the radius is only this equator, that the radius is the radius of the earth. So is the radius. Another thing we need to know is that we need to get this angle. Yes, because for us to calculate the length of arc, we need the central angle. And how do you do it? So if you take this as, we need to, common sense will tell us that since they are of different hemisphere, that's north or south, you see that the angle here is the addition of these two angles, theta 1 plus theta 2. Because if we take this as the latitude 0, so if you move up, is theta 1. That's, I'm saying that if you partition this first part is theta 1, while the second part is theta 2. So the total angle is theta 1 plus theta 2. And if you could remember our formula for length of arc is always angular difference. So I'm saying that from here, AB, which is the length of arc, is always angular difference which is that's latitude over 360 times 2 pi r, where r is the radius of the earth. So that's it. So if they're of this, it depends if they're of this same hemisphere. So assuming I draw, okay, maybe let me use the equation to explain that. Okay, look at this question. We're asked to, okay, look at this. They say 2 points A and B are on the earth's surface. Calculate the distance between A and B to the nearest kilometer. So see my globe. So let's locate the point. They say 30 knots and 30 knots, 30 west. So see the west. So if I take this to be 30, let's take this to be 30, or maybe, okay, let's take this, the red one, to be 30 west. So this 30 west. So they said 30 knots. So if I take this to be 60 knots, because I have 60 and 30, so this 30 knots. So the first A, the point of intersection of 30 knots, that, so the first one is this. So this is my A. While my B is 60 knots, 30 west. So the same 6. So do you see it? They have common longitude. So the distance is along the longitude. And this is my center, as you can see. So if I join the radius, this is my radius. So the radius is r and r. So let's get the angle. So as you can see, the equator, the radius is 0. So if we start from 0, assuming, okay, let's take this to be the axis. So they said from here, from here to here is this 30 degrees. Have you seen it? So that's how we moved 30. So this is 30. Why from here to that same, from here to here is 30 degrees. This is 30. Why from here to here is 60. So since here is 30, so the remaining should be 30 to make it 6. So 30 plus 30 is 60. Do you see the logic? See what I mean? Let me draw it out. We have something like this. So from here to here is 30 degree. Why from here to here is 60. This is 60 degrees. So meaning that here is 30, here it should be 30 to make it. So 30 plus 30 is 60. This is A and this is B. So we are to find this. So using our formula for length of arc, we can easily see that AB is, the angle is 30. That's the difference. 60 minus 30, that's 30 degrees over 360 times 2 pi r. So we take pi as 3.14 maybe 2.8 times the radius of the earth r. We normally, the radius of the earth is always 6,400 kilometers. So we've used our formula 2 pi r. So we can calculate, this is, you can multiply, let me get my calculator. So if you multiply 30 times 2 times 3.1428 times 6,400 divided by 360. So the answer is 3,352.32. So this is 3,352.32 kilometer. So which is approximately 3,352 kilometer, because they say to the nearest kilometer. So you need to draw a clear diagram so that you can solve any question on that. Thank you. Okay, we're on distance between 2 points along the latitude. We've done longitude, and as you can see from the diagram, for us to find the distance, like assuming this, if you are given maybe this point A and point B, and we are asked to find the distance between these two. This is an arc of this circle. So if this is the center, so once we know this is the radius, this is small r, let's use small r, because the radius of the earth we normally use big R, which is 6,400 kilometers. So you see that, you notice that the radius we use for distance along the latitude is different from the radius we use, because they are not the same. It's only the equator that the radius is the same as the radius of the longitude. As you can see, if you connect here to here, is a big radius, which is r, because this is a big circle. So let's now find the relationship between small r and big R. So assuming we are given this, so if I join these points, I've joined I've joined some points. So if we call this the radius of the Earth, that's the big radius for the R. So assuming from here, this is the center of this small circle. So if I call this the small radius, the radius of this small circle, so I want to relate small r and big R, but we need an angle. So assuming this is the latitude, remember we measure latitude from horizontal. So if I call this phi, so you can see that, remember this is 90 because this is a straight line, this is a triangle. So if you look at triangle, maybe let's call it triangle A, B and O, that's triangle OAB. If this is phi, this is also phi by alternate angle theorem. Do you remember alternate angle theorem? This is a transversal. So using our soccer tour from elementary trigonometry, that cos phi, cos is always adjacent over hypotenuse, so which implies that small r is always r cos phi, where phi is the common latitude. I told you for us to find the distance along the latitude, we must have common latitude, but if it's along the longitude, they must have common longitude. R is the radius of the Earth, while small r is the radius of the small circle, or maybe let's call radius of the latitude. Maybe let's write radius of the small circle. So each time we are to find, from what I just explained now, that if you are to find the distance between this A and B, since this is a circle, we know that the distance is always is a length of arc now. So angular difference, so depending the angular depending if they're on different hemisphere, even on the, as you can see, they're on different, so we add. So I will use example times 2 pi small r. So we are not using the big R now because we are on this small circle, so we use small r. So let me use the equation to illustrate this. So they say 2 points, this and this, are on the Earth's surface. If it takes an airplane 10 hours to fly from A to B along the parallel of latitude, calculate its speed. Okay, we know that speed is always distance over time. So we need to get the distance first before we are given time. So once we know the distance, we found the speed. So let's draw the diagram. So look at my globe. So if I locate this is 30, so they say 30 north, 60 west. Why this is 30 north, 30 east. So they have common latitude of 30. So if we call here, let's call this 30, latitude 30 north. So why this is 60 west, why this is 30 east. So if I take this as my longitude 60 west, why this, let me take this as my longitude 30 east. So as you can see, both have common. So this is point A, while this is point B. So we want to get this length. So as you can see, this is the middle of this circle. So the radius we are going to use here is the small r, the same small r. So for us to get, remember, we measure latitude from, let me use a straight line so that, okay, we measure, okay, let me just draw. So see what we have here. This is my axis, this B, and this is A. So this is my small r. So let me use 0 subscript 1 to denote the center here. So the first one is 60. So here is 60 west, while this is 30 east. So my total angle is 90. So to calculate AB is very simple now. The angular difference is now 90 degrees. So 90 over 360 times 2 pi r. So times, let me use 22 over 7 times our r. Remember, I told you small r. Small r is big R cos phi, where phi is the common latitude. Well, I proved it here. So the radius of the earth is 6,000. Always remember that 6,400 cos phi is 30 degrees. So this is 1 over 4. So this is half. You get this 120 over, so this is half times 22 over 7 times 6,400. Cos 30 is, I think it's root 3 over 2. So we can see that this is 2 to 11. So 11 times that is, so I have 11 times 6,400 over 14 times root 3, times root 3. So let's find the product. We have 11 times 6,400 times root 3 divided by 14. So we have 8,709.7. So we have 8,709.74 kilometer. But remember, we are asked to find the speed, not the distance. Therefore, the speed is 8,709.74 over 10 hours over 10. So this is now 870.974 kilometer per hour. Or they say to the nearest kilometer per hour, so which is approximately 871 kilometer per hour, the nearest kilometer. So that's the answer. So please, whenever you're asked to solve this, just draw a clear diagram. You are good to go. So they said the ratio of the diameter of the earth to the distance between A and B is, well, as you can see from the picture, you see that A and B lies on the equator, and the equator is a great circle. So the radius of the equator is the same as the radius of the earth. So using our distance formula arc, we know that AB, the distance is the angular difference. As you can see, this is 60. The longitude of A is 60, while the longitude of B is 30. So since they are of different hemisphere, okay, let me just join. So this is 60, why this 630? So the angular difference, I have an arc something like this. So I have something like this. This A and this B. The angle here is 60 plus 30, which is 90. So to find the length of arc AB is now 90 over 360 times 2 pi r. Yes, because the equator, the radius of the equator is the same as the radius of the earth. It's a big circle, and we're asked to find the ratio of the diameter, and you know this 1 over 4. The diameter, you know, this is circumference, so we can write it as pi d. So pi d over 4. This is 1 over 4. 2 radius is diameter. So if you now find the ratio of the diameter to AB is now 4 over pi. Yes. AB is equals to pi d over 4. So d over AB is now 4 over pi. And we know that pi is 22 over 7, which is 4 times 7 over 22. So we have 14 over 11. So what we are looking for is 14 is to 11. So option B. So it's a very simple question. Thank you. Okay, they said we are given the diagram. We are asked the ratio of the circumference of the earth to the distance between C and D is dash. This is very simple question. Looks hard, but it's not hard. So just logic. CD and CC. So we are talking about distance along the small circle, and we know that the distance is always the angular difference. Angular difference you add or subtract depending if the longitude are on different hemisphere. As you can see, this is 60, this is on 60, longitude 60, while C is on longitude 30. So they are different. This is west and this is east. So we add. So we have 60 plus 30 over 360 degrees times 2 pi. Remember, this is small circle, and I've done the relationship between the small circle and the radius of the earth. Is always the radius of the earth cos the common latitude. As you can see, they lie on 60 degrees, so 60. So what we have here is 90 over 360, which is 1 over 4, and cos 60 is half. So I have 1 over 4 times 2 pi r is the circumference of a circle times half. Cos 60 is half, CD. So we're asked to find the ratio of the circumference of the earth. So which implies that the ratio circumference of the earth over CD, the distance between CD, is now 4 times 2 is 8, 8 over 1. Yes. Because this is like circumference over 8. 4 times 2 is 8. So the answer is 8 is to 1. So it's a logical question. Very simple. Option D. Thank you. Okay, look at this. We ask if A with latitude phi and theta 1, longitude theta 1, and B, latitude phi and theta 2. Then we're asked to find the distance between A and B. So before now, in our introductory video, I said that for us to find the distance between 2 points on the Earth's surface, they must have either common latitude or common longitude. And if they have common latitude, means that the distance is along the latitude. While if they have the common longitude, the distance is along the longitude. So looking at this question, they have common latitude, so the distance must be along the latitude. And we know that the distance is always the angular difference. Since the distance is along the latitude, the angular difference will be either addition or subtraction of the longitudes times 2 pi r, and the r we are going to use